Hello, welcome to the session Data Structure Sorting Gate Questions. At the end of this session, the students will be able to solve a data structure problems. Gate 2021, the question is given: which algorithm out of the following options uses the least number of comparison among the array element to sort the above array in ascending order? The array is given here: 23, 32, 45, 69, 72, 73, 89 and 97. So you can observe that the array is not nearly but already sorted. So here the options are given: selection, merge, insertion sort and quick sort. Now we will see. Now first, initially we are having the insertion sort. It is like the card how we play. That idea is like sorting a hand of playing card. So here what we do, here we are having cards. Different numbers are on that card and we need to remove one card at a time from the table like this. We have to take one card from the table and insert into the correct position in the left hand. So whatever we are containing this card in the left hand, we have to pick with this one card and now we have to insert. At that time what we do, to insert this 15 we need to make room for it. Where to insert, we will check it, compare it with each card and then we will be making insertion. So for that we have to move 30 and then 20 like this. We have to move 30 and then 20 and 5 and 10 are already there. So our card can insert here. So this is the way we are doing the insertion sort. Now we are picking one by one number. We are checking where its place is there and then we are keeping at the proper place. So we will see that. So here first 5 is there, then we will be incrementing our index. So 2 will be our number. 2 will be checked or compare with this left side. Now 2 is smaller than 5, so we are going to swap that number. So now next will be 2, 5 and our index will be increased. Now index will be at third position and our number is 4. So 4 will be compared with 2, 4 will compare with 5. Now 4 is lesser than 5, so it should be in between 2 and 5. So 5 will be shifted and 4 will be inserted. Then next we are going to the next index. So it will be 6. Again the 6 will be compared with 2, 4. Again it is greater. So again it will compare with 5. Again it is greater. So we are not moving 6. Next index will be 1. Now 1 will be compared with the left side array. That is, first it will compare with 2. So 1 is smaller than 2. So we need to shift 1 here. Then we have to make the room for that. And then 2 has shifted. Then 4 has shifted its position, 5 and 6 like this. Our 1 is inserted at the proper place. Now next number is 3. Now 3 number, again it will be checked with this left side array. That is the first 1, it is a smaller, it is okay. 2 is smaller, okay. Now when it is compared with 4, it is smaller than 4. So we have to again make the room for this 3. So 3 will be here and then 4 will be shifted, 5 will be shifted and 6 will be shifted. So in this way the insertion sort works. Now we will see. So this is the first we have done. So we have swapped in this first case 2 and 5. Then the j is incremented and then it is compared the next value and it is shifted then there is a no shift when the 6 is bigger one, and then for making room we have shifted by 1 every number. So for 1 we have to make room here, so it is everyone is shifted like this. In the last we have done the shifting of only 4, 5, 6, 4, 5, 6, and thus we have done this insertion sort. Now as the question is given in the gate that it is a sorted array, just we will see on the sorted array how it happens. Here first the index will come here at the second position, so 2 will be compared with 1, so it is a no swapping. So here 2 is not swapping and it will be compared once. Then next it will come to the 3, it will be compared, no swapping. Then next 4 will be compared with everyone, no swapping will be there, nothing will happen. 5 will be compared and 6 will be compared. So how many numbers are there, that many comparison will be happen. So here we are having 6 numbers, 6 minus 1, that will be 5 comparison has happened. Now as per the gate question we can say that the insertion sort is better, as we are having given the array is almost sorted in ascending order. So insertion sort will give the best case time complexity of order big O notation n. So here answer will be C. Now this is the insertion sort. You can see this is the algorithm for the insertion sort. For J we are starting from the second position, so from the second position to n position we can go. Then the key will be there, whatever the number of J, that position we will be having key first here, that is the second position, so it will be 4 will be compared with its left. So here the key is there, A of J. Then insert A of J into the sorted sequence. If we will compare when to insert that, while A is greater than 0, I is greater than 0 and A of I is greater than key. So then only we are going to do this thing, that is do A of I plus 1, we will be comparing with A of I, and then we will be decrementing and then we will be keeping the key. So in the sorted array there is no need to swapping, just it will be the comparison will be happen. So here it is a good running time when it is almost sorted, that is the array is sorted, so it is a n time it will be checked. But when it is a worst, means it is a exactly reverse or it may be worst case, then that time we need swapping. We have already seen that all the swappings, how many swappings we need to do. So 2 times we have to do this. So it is a big O notation n square running time in the worst and average case, and that time we will be required the comparisons are n square by 2 and exchanges. So here one more question on the insertion sort. You have to answer this. In insertion sort, which condition will be correctly implement the while loop? So here the conditions are given. You just pause the video and answer the question. So here the answer, this is the again gate question is there. So B answer is correct, just we have seen how it is implementing. j is greater than 0 and it is not that or. Either this condition or this condition will not work out, but you can see this condition is stable, so this will be compulsory. Only and or we have to check. So and condition is appropriate because both condition has to be correct or valid. Now in that again we will see this side conditions. So here the array j minus 1, if it is greater than value, then we are going to shift. So in that way, in insertion sort, the element is a of j is inserted into the correct position in sort sequence from 1 to j minus 1. So condition will be j greater than 0 and array j minus 1 is greater than value will be implemented while loop correctly. So we have already seen how implementation we have done. These are references. Thank you.